Hello everyone, I am Pavitra Devi working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science. Now I am going to take the class about classification. In data science, classification refers to the type of supervised learning where the code is predict the categorical label of the given input based on the set of future. The main objective is to map input data and to predefine the classes or labels. Next one, key concept of classification. Classification is the subset of supervised learning where the model is trained on the labeled data set. That is, the data contained but input features and corresponding output labels. Classes are labels. The output variable in the classification is categorical. For example, email spam detection. The class might be spam or not spam. Future. These are the attributes or variable of the data that are used to make the prediction. For example, in the credit card fraud detection task, the future might include transaction amount, time transaction, etc. Training and testing. Training set a data set with known label used to train the models. Test set a separate data set used to evaluate the performance of the trained models. Next one, types of classification. There are three types of classification. First one is binary classification. Involve two classes. Example, yes or no, spam or not, anyone. For example, predicating whether the patient has the particular diseases, positive or negative. Multi-class classification involve more than two classes. The model needs to classify the data into one of the multiple possible cases. Example, classifying different types of animals. Example, cat, dog, rabbit. Next one, multi-able classification. Each input can be assigned multiple labels. Example, predicating tags for the document that could be belong to the multiple categories like sports, health and fitness. Next one, uses of clustering. Clustering algorithms are majorly used for market segmentation. Business use clustering to group their customer and use the target advertisement to attract more audience. Market basket analysis. Shop owners analyze their sales and figure out which items are majorly bought together by the customer. For example, in USA, according to the study, this diaper and beer were usually bought together by fathers. Next one, social network analysis. Social media sites use your data to understand the browsing behavior and provide you with the targeted friend recommendation or content recommendation. Next one, medical imaging. Doctor use clustering to find out diseased areas in diagnostic image like X-rays. Next one, anomaly detection. To find out outliers in a stream of real-time dataset or forecasting. Fraudulent transaction, we can use clustering to identify them. Next one, simply working with large dataset. Each cluster is given a cluster ID. After clustering is complete, now you can reduce your future sets, whole future sets into the cluster ID. Clustering is effective when it can represent a complicated cases with straightforward cluster ID. Using the same principle, clustering data can make complex datasets simpler. Next one, common classification algorithm. First one, logistic regression. Despite the name, it is used for the classification as purely binary classification. It estimates the probability of an instance belonging to the classes. Next one, decision tree. A tree like a structure where each internal node represents the decision based on the future and each leaf node represents the class label. Random forest, an ensemble method that uses the multiple decision tree aggregated their predication to improve accuracy and reduce overfitting. Next one, support vector machines, a powerful classifier that find the hyperplan that best separate data points of the different classes. Next one, Navy based on the Bayes theorem. Algorithm assume the futures are independent. It's simple and works with the text data. Hey nearest neighbor, classify the data point based on the majority of the class nearest neighbors. Neural network, complex model capable of capturing intricate relationship on the data. Next one, performance metrics. There are a lot of performance metrics: accuracy, precision, recall, sensitivity, F1 score, confusion metrics, ROC, AUI, score rate. Next one, challenges of classification: imbalanced data, overfitting, future